Hello, everyone. Welcome back to Epidemiology and Biostatistics. Our topic today is measurement of risk, and I am Dr. Muhammad Razif Shahril. The topic learning outcome today is at the end of this lecture, you should be able to define and calculate relative risk and odds ratio. What is relative risk and odds ratio? So relative risk and odds ratio is a basic measures of association. We often need to know the relationship or association between an outcome, probably a disease, and certain factors, example, age, sex, race, smoking status, and dietary intake. So relative risk and odds ratio is used to guide planning and intervention strategies. In calculating measures of association, that is odds ratio and relative risk, we need a 2 by 2 contingency table. What is 2 by 2 contingency table? So in this screen, you can see that there is a table which have two columns and another two rows. The columns are outcome, whether it's present or absent. And the rows are the exposure, whether it's present or absent. So a contingency table totals up each rows and the columns and tally it as a big total here. The exposure is a broad term that represents any factor that may be related to an outcome. Example, whether they are a smoker or non-smoker, whether they are a consumer of high fiber diet or low fiber diet, or whether they are consuming high fat diet or a low fat diet. This slide shows an example on how to use a 2 by 2 contingency table. An outcome is a disease or condition, whereas an exposure is a factor that may be related to an outcome. In this slide, we use cancer as the outcome and smoking as the exposure. When we say the outcome is present, we can also write positive cancer, and when it's absent, we can write as negative cancer. It simply means that in this present group, these are patients with cancer or diagnosed with cancer, whereas in absent group are patients who are not diagnosed with cancer or a healthy control. In the present exposure group, these are the smokers or those who are exposed to smoking. And in the absent group are those who are non-smokers or not exposed to smoking. So A is the total number of cancer cases who are smokers, while B is non-cancer or healthy controls who are smokers. C is the number of cancer cases who are non-smokers, while D is healthy controls who are non-smokers. So the total for the present outcome is A plus B, while the absent outcome is B plus D. The total for the exposure present is A plus B, and the absent for exposure is C plus D. And the whole total subjects involved in this 2 by 2 contingency table is A plus B plus C and plus D. The first measures of association that we will explore is relative risk. Relative risk is a ratio of the incidence risk between two groups. Relative risk can only be calculated from prospective studies or cohort studies. A prospective study, sometimes called a prospective cohort study, is a type of cohort study or group study where participants are enrolled into the study before they develop the disease or outcome in question. They will be followed up for a certain time until the disease is detected. The interpretation of RR is when the RR or relative risk is more than 1, it means that there is an increased risk of outcome among exposed group. When the RR is less than 1, it means that a decreased risk of protective effects among exposed group. And when the RR is equal to 1, it means that there is no association between exposure and outcome. The formula for relative risk calculation is RR is equal to incidence rate among exposed divided by incidence rate among non-exposed. Here is an example how to do a relative risk calculation. This 2 by 2 contingency table will help us to calculate the relative risk. So our relative risk is incidence among those exposed divided by incidence among those not exposed. So A is those who are incidence with exposed divided by total those who are exposed, means that A divided by A plus B. And this figure is divided with incidence among those who are not exposed. So C is divided by total who are not exposed, C plus D. Let's look with the working example. This is the contingency table here. So A is 354, B is 143, C is 293, and D is 511. So RR is equal to A divided by A plus B, and the total is divided by C divided by C plus D. When you do the calculation, you get an RR of 1.95. Before we move further, let's understand what is probability and what is odds. Probability is chance or risk of an event occurring, or a proportion. Probability is equal to number of times an event occurs divided by number of times an event can occur. Meanwhile, odds is a ratio of the probability of an event occurring to the probability of an event not occurring. So odds is equal to probability divided by 1 minus probability. The odds ratio is a ratio of two odds. The odds ratio can be calculated for all three study designs, that is, cross-sectional, case control, or cohort study design. There are various approaches to odds ratio. The first one is a cross product or odds ratio, which uses to do 2 by 2 contingency table, AD over BC. The second one is prevalence odds ratio, which can be derived from a cross-sectional studies. Third one is exposure odds ratio, or odds of exposure in disease versus non-disease. This can be measured in rare cases or exotic diseases. The fourth approach is disease odds, or rate odds ratio, odds of getting a disease if exposed or unexposed. This is a common odds ratio being used in studies involving cohort and cross-sectional. And finally, we could calculate risk odds ratio using cross-sectional studies, cohort studies, and also case control studies. Therefore, odds ratio for cohort and cross-sectional studies is a ratio of the odds of the outcome in exposed person to the odds of the outcome in non-exposed person. Odds ratio for case control studies are ratio of the odds of exposure in cases to the odds of exposure in controls. Odds ratio can also sometimes provide an estimate of the relative risk when the outcome is rare. Now let's look how to do the odds ratio calculation using the 2 by 2 contingency table. Odds ratio is a ratio of the odds of exposure in cases, that is A over B, to the odds of exposure in controls, that is C over D. If we simplify this formula, we will get A times D divided by B times C. The working example uses similar figure with the relative risk calculation. Therefore, odds ratio is 354 divided by 143, and this total is divided by 293 divided by 511. You will get an odds ratio of 4.32. The way we interpret odds ratio is also similar with the way we interpret relative risk. Odds ratio of more than 1 means that there is an increased odds of exposure among those with outcome. Odds ratio less than 1 means that there is a decreased odds or protective effects among those with outcome. An odds ratio equal to 1 means that there is no association between exposure and the outcome. By now, you should be aware that keeping the terms right is very important. Risk ratio is equally to relative risk, while relative odds is equal to odds ratio. We must remember that the key is recognizing the term risk and the term odds. In terms of appropriateness of measure, the relative risk can only be calculated in a prospective study. Meanwhile, odds ratio can be calculated for any design, including cohort or prospective studies, case control studies, and cross-sectional studies. The inference in measures of association is The relative risk and odds ratio provide the magnitude of difference between some factor and an outcome. But how do we know if the magnitude is statistically significant? Before we move to that, we must understand that a confidence interval is a range of values that is likely, example 95%, to obtain the true value in the underlying population. When we analyze odds ratio and relative risk using SPSS, all values of RR and OR will be accompanied by the 95% confidence interval value. If the RR is statistically significant, the 95 confidence interval value won't pass the value of 1. As an example here, the RR is 1.8 and the 95% confidence interval is 1.2 till 2.2, which doesn't pass the value of 1. When the RR or OR is not statistically significant, as in this example shown here, where the RR is 1.2 and the 95% confidence interval is 0.8 until up to 2.0, which passes the value of 1. It means that this RR value is not statistically significant. Let's look at an example on how to solve the problem involving odds ratio and relative risk. Question 1 is, Professor X conducted a retrospective case control study to identify whether salted fish intake increases the risk for developing nasopharyngeal cancer or NPC among 75 newly diagnosed NPC patients, which are cases, and 150 healthy controls. Among the cases, 50 were having a history of high salted fish intake, while among the controls, 100 were having a history of low salted fish intake. So, when we read the question here, it is important to identify the key points and figures related to the story here. The question is, A. Draw a 2 by 2 contingency table. B. Calculate the odds of consuming a high salted fish among those with NPC. C. Calculate the odds of consuming a high salted fish among those without NPC. D. Calculate the odds ratio and interpret the findings. And finally, E. If the finding above is from a cohort study, calculate the relative risk and interpret the findings. So let's solve this problem. First, you must understand the story, highlight the key points, and then you can start to draw the 2 by 2 contingency table. The situation is between the NPC and salted fish. So NPC is the outcome and salted fish intake is the exposure. So from the story here, we can fill up this 2 by 2 contingency table as shown in this slide. Total subjects involved in this study is 225. When answering the questions, we still need the 2 by 2 contingency table that we have developed just now. So to calculate the odds of consuming a high salted fish among those with NPC is 50 divided by 25, and the answer is 2. So the odds of consuming a high salted fish among those with NPC is 2. The next question asks us to calculate the odds of consuming a high salted fish among those without NPC. This is 50 divided by 100, and the odds of consuming a high salted fish among those without NPC is 0.5. The next question asks us to calculate the odds ratio or OR and interpret the findings. So let's use the formula for odds ratio, which is A times D divided by B times C. So we just put in the figures according to the alphabets. So this is A, B, C, and D. And the finding shows that the odds ratio is equal to 4. When interpreting this finding, we can write it as the odds of consuming high salted fish among those who have NPC is 4 times higher than those without NPC. And finally, the question asks us if the finding above is from a cohort study, we have to calculate the relative risk and interpret the findings. So we still use the same 2 by 2 contingency table we have developed earlier. And we replace the figures into the formula of relative risk. A divided by A plus B, and this total is divided by C divided by C plus D. A is 50, A plus B is 100, C is 25, and C plus D is 125. And this will give us a figure for RR equal to 2.5. When writing the interpretation, we can use this sentence. The risk of developing NPC among those who consumed high salted fish intake is 2.5 times greater than those who consumed low salted fish intake. Since the first question is quite easy, I have another question for you. A researcher conducted a prospective cohort study to identify whether saturated fat intake increases the risk for developing ischemic heart disease or IHD among 75,000 healthy individuals from Kuala Terengganu cohort study. After 10 years of follow-up, 5,500 developed IHD. Among those who developed IHD, 3,000 had a saturated fat intake of higher saturated fat intake, while among those without IHD, 9,000 were consuming a high saturated fat intake. The question is, draw a 2 by 2 contingency table from the situation provided. Second, calculate the relative risk and interpret the findings of relative risk. The next question asks us if the finding above is from a case control study, calculate the odds ratio and interpret the findings on odds ratio. Oops, where is the answer? I would like you to try it on your own and compare your work with the answer provided later in the comment section. With that, thank you and see you again in the next lecture. Bye.